We're now on page 12 on geometric probability, finding probabilities using length and finding probabilities using area. So if we scroll down through the review of probability that we discussed on a previous video, we get to the section on geometric probability, and the first one we're going to cover is finding probability using length. Okay, so if I know on this example that they want me to find the probability that a point M is going to fall on segment KL to the far right, KL is the segment that is part of RS. So the success would be that you land anywhere on KL. So we need the length of KL to be on top, and then the length of the entire segment is RS. And so the probability of favorable outcome would be that it falls on KL, and then the total number of outcomes would be it falls on RS somewhere. So the ratio of the length of KL over the length of RS would give me my probability. So on the actual example that we're going to complete together, right below that, point X is chosen at random on AD, which is the entire segment. Find the probability that X lies on AB. So AB is that segment. It has a length of 8. So 8 over the entire segment, which is 16, and that reduces to 1/2. Remember that probability can be expressed as a fraction, as a decimal, or as a percent. So 1/2, 0.5, or 50% is equivalent. So on exercise 1, point M is chosen at random on the entire length of ZP. Find the probability of each event. So what's the probability that M lies on ZQ? We would need to know the length of ZQ and put it over the entire length of ZP. In which case we have the length of ZQ is 2. And then the length of ZP is the sum of 2 plus 3 plus 5, or 10. That reduces to 1/5, 0.2 if you convert it to a decimal, or 20% if we change that decimal to a percent. Now, the next question is asking what is the probability of it landing on QR, which is got a length of 3. So that would be 3 over 10, or in other words, 0.3, or 30%. Lastly, for exercise 3, what's the probability that M lies on QP? QP is the sum of 3 and 5, so we get that would be 8 out of 10, or when reduced, 4/5. When converted to a decimal, 0.8, or 80%. On the next page, we're going to deal with a problem that has time in it. In a 5-minute traffic circle, a traffic light is green for 2 minutes and 27 seconds, yellow for 6 seconds, and red for 2 minutes and 27 seconds. What is the probability that when you get to the light it is green? So we would need to know how many minutes it is for green. So in the case of the units, time units of measure here, we have minutes and seconds. So we want to be able to convert to one or the other units. I'm going to pick seconds. So there's 60 seconds in a minute, which makes 2 minutes 120 minutes plus the 27, which is 147 seconds. So that's the lapse of time for green. So we're going to go ahead and put 147 over a total time span of 5 minutes. And 5 minutes, when converted to minutes, is 300. So 147 over 300 reduces to 49 over 100, and that is 0.49, or 49%. Okay, so the next one is another unit of measure, this time gallons. Your mom's minivan has a 24-gallon tank. What is the probability that when the engine is turned on, the needle on the gauge is between 1/4 and 1/2? So if you're looking at the gauge, and 1/4 being 1/4 full is down here where this is empty, between 1/4 and 1/2 you have a quarter of the tank is what is the probability that it's between that? Well, that's a quarter of the tank, so 1/4, or 0.25, or 25%. So the value between a quarter and a half is a quarter, or in other words, 1/2 minus a quarter is a quarter. And then our last example will be on finding probability using area. When you're determining geometric probability, especially with targets, and you're trying to figure out what's the probability of you landing within a certain region, you're going to take the area of the part that you want to land in and divide it by the entire part of the figure that you could have landed on. So kind of like the total area versus the targeted area. So in the example below, suppose a coin is flipped into a reflection pond designed with colored tiles that form 3 concentric circles on the bottom. The diameter of the center circle is 4, and the circles are spaced 2 feet apart. What is the probability the coin lands in the center? And the center being the shaded part, this area right here. So that center circle has a radius of 2. So we're going to find the area of that circle that's highlighted and take it over the area of the entire circle, which I'll highlight in pink, over the area of the entire circle, the bigger circle. So we'll start with the area of the little circle, the highlighted one. That is pi r squared, where r is 2. And we're going to divide by the area of the bigger circle. Well, if the radius of the small circle is 2 and the circles are spaced 2 units apart, this would make this unit on this side 2 and then another 2. So the radius of the larger circle is 6. So we're going to divide it by pi 6 squared. So when I reduce that, I get 4 pi over 36 pi is about 1/9. So my probability is approximately 0.11, or